That's going to be measuring oxygen consumption and CO2 production, and ventilation, which is total air volume moving back and forth, okay? And so when we do that, we'll get that oxygen value, we'll get that CO2 value, right? And that'll, one of the things we'll get on the machine is this thing called RER, right? And so RER is a ratio of CO2 to O2. So if that RER is 6/6 because of this, right? So this is glucose. It takes 6 moles of oxygen to burn glucose. We get 6 moles of CO2 produced when we burn that mole of, or that 1 mole of glucose there. So that's a ratio of 6/6, right? So if the RER is 1.0, we know we're burning 100% carbs. Okay, this is a very common fatty acid in the body, palmitic acid. It takes 23 moles of oxygen to burn that fat, okay? But we only get 16 moles of CO2 out of it. So 16 divided by 23, that's 0.7, okay? So then we know if our RER is 0.7, we're burning 100% fat. Okay, so that's the way RER works, okay? Questions on that before we keep going? Okay, so this table here on the next slide is going to be the one that we're going to use for class today, okay? So again, if our RER is, this one has 7.71, but 0.7 is very close to that, obviously. That means we're burning no carbs and 100% fat, but the number that we're going to need for our calculations is this one. We're going to need how many calories do we get out of each liter of oxygen used when our RER is 0.7, okay? And in that case, it's 4.69, okay? If we're all the way on the other side and our RER is 1.0, that means we're 100% carbs, no fat burning, and we get 5.05 calories per liter of oxygen used, okay? So this number is key in understanding or in being able to calculate calories burnt, okay? So this is our equation that we're going to be working with today, guys. So calories equals VO2 in liters per minute, okay, multiplied by the number that we get from right here, that RER to kcal equivalent, okay? And then we just multiply it by time. How many minutes were they at that VO2 and at that RER for? And putting those 3 numbers in, we'll get the number of calories burnt, okay? So we're going to do that here with multiple examples in 1 second, okay? So let me just close the loop here on something real quick that I was just showing you in that Canvas, on that Canvas page. So when you see this RER, that expanded RER kcal table in the last sentence there, okay, right next to where I just put that, that's a similar table that shows you how many calories per liter of O2, but it has everything all the way from 0.7 to 0.71 to 0.72, 0.73, 0.74, all the way up to 1.5 or something, okay? So that's the one you're going to want to use for that lab, okay? Because you're going to get an average RER in that data that is not exactly 0.7. It's going to be 0.73 or something, and there's nothing in that table to tell you what to do with 0.73, right? It goes from 0.71 to 0.75. So that expanded one has all the little numbers in between, okay? So don't use this one from the notes. Use the one attached in that PDF, okay? Questions on that? Does that make sense? Okay. All right, so let's hop over to this question right here, okay? So I am, here's what we'll do. I'll go ahead and walk us through this one together, and then for the next one, the next 2, I'm going to send you into your breakout rooms to work on as teams, okay? So the question here: an individual consumes a volume of 2 liters of oxygen per minute, okay? So that means the absolute VO2 is 2 liters per minute, okay? Average RER is 0.8, exercise for half an hour, okay? So our equation from the previous slide was kcals equals VO2 in liters per minute, okay, multiplied by the, exactly how does that one express? Kcal, RER, kcal equivalent. Yeah, so RER to kcal equivalent, and that one is in, the units for that one is kcals per liter of O2. And then we just multiply that by time, and time has to be in minutes, okay? So what do I put, and someone could just just to unmute themselves and yell this out. What do we put for VO2 with this problem here?
2.
2, perfect. 2 liters per minute. Okay, what do we put for the next one by using that table? So you can take that 0.8 and go back to the previous slide and pull that other number. Somebody tell me that.
0.8.
Okay, so the 0.8 we use, and we go back to this slide and we find 0.8, and then we see what number's next to it on the right.
4.80.
Thank you. 4.80, perfect. Okay, so 4.80, and the unit there is kcals per liter of O2. Okay, and then we multiply that by time. How many minutes did they do this for? You can hold it up in
30.
30, perfect, thank you. 30 minutes. Okay, so yeah, first, before we do the calculations, let's just look at the units, okay? Let's look and see what the units do, okay? So right here, we've got a liter of O2 on the top, and we have a liter of O2 on the bottom here. So those are gonna cancel, right? Those are gonna cancel. We have a minute over here, which is technically on the top, right, a numerator, and this one was on the bottom here, all right? So those minutes are gonna cancel. So what units are we left with?
kcals.
kcals, perfect, okay? Maybe somebody's already done that calculation. What's our number? Say it again.
288.
288, perfect. So we got 288 kcals, okay? So that's the way that we calculate energy expenditure from VO2 data, okay? And this is really the best way to do it, right? We got all these watches and activity monitors and our phones now that tell us how many calories we burn when we're doing stuff. All those equations that those devices use, they come from studies that use indirect calorimetry and then kind of with a big data set and came up with numbers that they can plug into an equation, right? Okay, so questions on how we did that one? Okay, so it's pretty simple. Okay, let's go to this next one. Okay, so I'm going to give you some numbers here, and then I'm going to send you into your breakout rooms and have you do this as a team. Okay, so average VO2 at rest is somewhere around, let's call it 0.25 liters per minute. So that's your average resting VO2, and this varies greatly depending on your body size and your muscle mass. Okay, so larger people have a greater resting VO2. Smaller people have a smaller resting VO2, okay? Average RER, we're just gonna say, was 0.75 on there? Yeah, it was, okay. So we're gonna say 0.75, okay? And then how many minutes are there in a day? You guys know? What do you do?
1440.
Perfect, 1440, thank you. 1440 minutes per day. Okay, so now what I want you to calculate is 24-hour energy expenditure. All right, so how many calories would somebody burn if their VO2 was 0.25, RER was 0.75, and they did that for all 24 hours, which is 1,440 minutes, okay? All right, I'm gonna send you in your groups, and so now's a great time, if you're kind of not sure how these calculations are being done, now's a great time to ask the people in your group, get some help, figure it out, okay? And I'll give you a few minutes to work on that one, all right? Here we go. Laura and Rachel, you guys click the prompt to go to your room. Maya, are you there? All right. Everybody send it in? Send something in there, okay. Yeah, so it looks like most of us are saying 5,000, some of us are saying 500, so we could have had a conversion error there, which is common for these, so good to figure those things out right now. Okay, all right. Good, looks like everybody's still, a couple still sending those in. Joey had offered, I don't know if he offered actually, I just asked him to share the way that they did their work. So Joey, would you mind putting that up there for us? Yeah, so let's take it, and why don't you talk us through just the steps you did there, if you don't mind, Joey, or anybody else in your group that wants to. Somebody would have to unmute to make that happen.
70 milliliters times his body weight, which is 70 kilograms.
Okay, so we're doing the first step is you're getting that kilograms out of there, right? That was the first step. Okay.
My math is a little weird, but and then divide that by 1,000 to convert it to liters.
Okay.
And then 70% of his VO2 would be that number divided by times 0.7. I don't know why I put divided by. Maybe I did. I don't know.
Okay.
Times
up with it. Well, okay. Times the 0.7. Okay. So you kind of maybe even like that. I don't know if you can see my screen. Is that kind of more what you did?
That's better.
Yeah. Yeah. Okay. So let's just make sure we're on the same page there. So we need to get kilograms out of it, and since kilograms are the denominator, the way we get a denominator out is to multiply by that same thing, right? And that's why I gave you his weight. So that's what Joey did there. He took that 70 mLs per kg per minute, multiplied it by kilograms over 1, right? So that's going to cancel out our kilograms. And then we want to turn this mils into liters. So we're going to have 1,000 mils per 1 liter, right? Yeah, so then we're going to, so that divided by 1,000. So that really we're just moving the decimal place 3 places to the left, right? And that's probably where the one group that was sending in 500 instead of 5,000, most likely you just move the decimal place 2 to the left instead of 3 if you got the 500. Okay, can you put that back up there for us, Joey? It was really nice.
I may have erased it. It was messy. It was messy.
I was liking it. Does Jordan or Maddie have it from your group?
I'm not in his group, but yes, I have it. But it's
okay. Sorry. Oh yeah, that's pretty hard to see.
That...
I'll write it here. You guys can just help me. I'll write it in. So what number does that give us in liters per minute for his VO2 max?
4.9 liters per minute.
Okay, 4.9 liters per minute, but that's VO2 max, right?
Yeah.
And we don't exercise at VO2 max for very long, definitely not for 5 hours. We can do it for a little bit, but not for 5 hours. So how do we get that to 70%?
Multiply it by 0.7.
Okay, multiply by 0.7. All right, and what does that give us?
3.43.
3.43, that's liters per minute. Okay, good. All right, so now we got our VO2, right? That's our VO2 that we were looking for. The RER, we needed to get that kcal equivalent from the table. What was that?
4.86.
Okay, thank you, Jordan. 4.86. And then the time, 5 hours, how many minutes is that?
300.
Okay, 300 minutes. All right, so we got 3.43 times 4.86 times 300, and that's what gave us right around 5,000 calories, right? There was a decimal in there, but it was 5,000.7 or something, right? And that's actually believable, you guys. It sounds like a ridiculous amount of calories, but somebody who's riding a bike intensely for 5 hours would be expected to burn about that, about 5,000 calories in one of those days. So as far as the Tour de France goes, there's really no way that you can keep up calorically with that. They do their best, just eating all day and eating as much as they possibly can, but most of them lose weight. There's just no way around it. You just can't take in that many calories in your GI system in that span of time, but they got time to make up for it afterwards. So yeah, so they expected to burn about 4,000 to 5,000 calories a day on that. And that doesn't even include RMR, right? So that add another 2,000 to that for their RMR. So Okay, questions on how we did that one? It's a little more complicated with the conversions, but the basic equation is still the same. Okay, I wanted to take us to, yeah. Okay, I guess there was one here on exercise economy that I said I was going to do in class. This one's pretty basic, but I really just wanted to walk us through this one. So if we have two athletes who have this is their VO2 max, one with a VO2 max of 62, one with a VO2 max of 70. If this person's maximal sustainable VO2 is 91% of that max, and this one's 78, then we can quickly calculate this. You really would just do the 62 times 0.91. That would give you 56. So his maximal sustainable VO2 is 56 mLs per kg. The other one is 70 times 0.78, 54. Okay, and those are pretty close to each other, but the bottom line is this is why VO2 max isn't a great predictor of endurance performance in people who are all highly trained athletes, okay? Because their sustainable VO2 is much more important, okay? And that gets at two things that are kind of good at predicting that would be, number one, lactate threshold, okay? So somebody's lactate threshold is going to end up being a pretty good predictor of their maximal sustainable VO2, okay? And then also we talked about exercise economy being something that is connected to that as well. And so this previous slide shows that, where you have these two different athletes with the same VO2, but this guy's only at 55 mLs per kg when they're at 18 kilometers per hour, and this one's at 72. So subject B is going to have a much higher sustainable VO2, and that's really what's going to matter for a race pace, right? So when we take the women's cross country team at Point Loma and we want to see who's fastest, VO2 max number isn't going to tell us much about who's fastest on that team. They're all going to have a similar VO2 max. What's going to tell us more is what VO2 can they actually sustain during a race, right? And that would be predicted well by lactate threshold or by their exercise economy. Okay, any questions on that concept? Okay, and one thing I just want to clear up is this idea here that, so if we want to think about kind of three lines, so VO2 max is kind of our ceiling of intensity. We have lactate threshold down here, but that maximal sustainable intensity, also known as critical power or critical velocity, okay, that's the sustainable, maximal sustainable, and that should really be like your race pace, right? One thing I wanted to clear up is that we can exercise above lactate threshold, and we do all the time, okay? Lactate threshold is not the same thing as your maximal sustainable intensity. Usually your maximal sustainable intensity is somewhere around 50% of the difference between those two numbers there, okay? So we can increase that some by increasing VO2 max, but VO2 max isn't that trainable of a factor. But people who've already been training for years, their VO2 max isn't going to change much. But what we can change is we can increase this lactate threshold some, which by doing that, that will also push up the critical speed or maximal sustainable intensity a bit too. Okay, so that's just something I wanted to clarify there. Okay, any questions on that concept? Okay, I wanted to go through one more group of calculations with you guys while we're all together, and these will help you directly for your assignment, your lab assignment that's due on Monday. Okay, so this that I have pulled up here from Canvas, this is that expanded RER kcal table that I mentioned. Okay, so it has RERs all the way from 0.5 up to 1.5. Okay, so we'll come back to that in a second, but here is the Excel sheet that I shared with you that is the data you're going to be using to complete that lab. Okay, so let's just let's take a look, and we'll do the 3 mile per hour data. Okay, so you can see the different highlighted chunks. That's what you're using. Okay, so you're going to need to get the average VO2 that they had at 3 miles per hour. Okay, so I can do that for us right here. I'm going to click here, just the highlighted stuff. I'm going to highlight just the stuff there. Okay, and so one way to do this, if you have a little bit of Excel knowledge, it can be helpful. Let me go ahead and see if I can get there. Oh, that's not helping me. Yeah, I'm not so good on the iPad, but let me try it there. Yeah, it's not going to work on the iPad, but I can do it this way. Okay, so I'll just highlight, and then most of you with Excel, you'll have it here on the bottom. You see that on the very bottom of my screen where it says average 0.900572. Okay, so that automatically averages that for me. I can change what number that tells me. If I want it to be maximum, minimum, sum, whatever, but I change it to average, so I would have that. Okay, so there's our average VO2 during 3 miles per hour. Okay, so if you by mistake take this data too, that's going to change it, right? And that's going to give you the wrong number when you do your calculations. Okay, so you want to only include the highlighted data. Okay, so write these numbers down with me. Okay, so go 3 miles per hour, write down VO2 equals 0.90. Okay, let me pull it up on a note here as well so I can do the calculations myself. So VO2 equals, or sorry, 0.90. Okay, let's go back to that Excel spreadsheet. All right, what other number do I need to do my calculations? I need 2 more numbers, right? Somebody else that hasn't talked yet, tell me what else I need here. And sorry, you can see that VO2 is column B. What other column do we need?
We need a RAR.
Thank you. We're going to need RAR. Thank you, Alex. Yeah, so we're going to need RAR. So that's column G. So let's go here. We're going to click there. We're going to highlight this. We need to get an average RAR here. So the average is we're going to round up to 0.72 because it was 0.719. Okay, so RAR equals 0.72. All right, now let's go to that RAR kcal table, the expanded one, because 0.72 isn't in the one in our book, right? So 0.72, we got it right there. So that's 4.702. That's our number that we need, 4.702. So it's just the one that's right next to it, right? 4.72. Okay, so we put that in. So that's going to be 4.72. All right, so this is liters per minute. This is kcals per liter of O2. And then we need to know, then we need to know how long, if we wanted to get total calories burnt during this chunk of time, we need to know how long that chunk of time is. And let me just show you how that works on these, okay? So each of these rows is worth 15 seconds, okay? It's a quarter of a minute, right? And so that column A, that's the time column. It's in decimal format instead of seconds, okay? So it's like 0.66 is pretty much 30 seconds, right? But it's just whatever it's closest to, right? So with this one, we started at 10.26, so that's really 10 minutes and 15 seconds, okay? Because it's like a quarter of a minute, right? So we started at 10.25, and then we ended at 12.0. Okay, and we can really just count the cells if we want to be 1, 2, 3, 4, 5, 6, 7, 8. So 8, that's 2 minutes, right? Because it's 15 seconds per row. So it's just 2 minutes worth of data. Okay, so let's go back here. So our time equals 2 minutes. Okay, so if we want to calculate total calories burnt during those 2 minutes, we can do that, right? That would be 0.9 times our 4.72 times 2. Okay, go ahead and everybody do that calculation and send the number in on the chat for me when you get it. Yeah, my screen sharing failed. Let me come back to that. Okay, there we are. All right, so everybody's pretty much sending that in. So we got 8.496 calories, okay? That would be if we cared about the 2 minutes of calorie burning, okay? so that would be total calories in those 2 minutes. The questions in the assignment, in that Canvas quiz that you're going to complete, are more like, okay, if they're at this VO2 so this is 3 miles per hour, right? So this could be useful information for somebody. If they can walk at 3 miles per hour, we could tell them how many calories per minute they would burn, right? So how would we get at calories per minute instead of getting total calories, right? So the way that would be done is we just don't do the time part, right? That's all we need to do. Because let's look at our units there, right? If we have 0.9 liters per minute times 4.72 kcals per liter of O2, those are still going to cancel because of the liters. Now we've got a minute on the bottom and a calorie on the top. So if we want to know kcals per minute, then we just don't times it by the minutes. Okay, so what's 0.9 times 4.72? Somebody yell that one out or put it in the chat.
$4.248.
Okay, 4.2448 calories per minute. Okay, so that's going to be one of the types of questions you have to answer on there. It'll be how many calories would they burn per minute at this intensity. Okay, the other type of question will be, it won't be so much about how many did they burn during that highlighted period, because that's not 2 minutes, doesn't really matter. But let's say they went for a 30-minute walk at 3 miles per hour, right? How many calories would they burn for the 30 minutes? All we got to do now is we can take this number, times it by 30, and that's going to give us our value, right? So what's that one? Go ahead and send that one in the chat. 4.248 times 30. So that's going to give us, yep, about 127 calories. Okay, so you're going to do that for the 3 mile per hour, the 4 mile per hour, and the 6 mile per hour time slots there. Okay, so and remember, you're just using the highlighted data. Okay, so you got the green stuff for the 3 mile per hour, go down to the blue for the 4 mile per hour, and then you got this orange for the 6 mile per hour. Okay, and you're going to do the same calculations there. And then what you do with the resting is a little bit different. This yellow data on top is the resting data. You're still going to get an average VO2. You're going to get an average RER, but you're going to use that to get the 24-hour energy expenditure on a person, just like we just did, right? So you use that 1,440 minutes, and you will do those calculations with the 1,440 minutes, assuming that this is their true resting VO2. Okay. All right, guys. What questions do you have? Any questions on this you want to ask? Okay. I hope that you feel comfortable to reach out to members of your group, of your team, if you need some help on any of this stuff or help in this class, and also me too. I'm happy to set up a time with you to talk as we move towards the more material in this course. You can always go to my virtual office hours link in Canvas too, which is you can click on that and sign up for an appointment. I've got appointment slots available multiple days a week, so you can sign up for something if you want to talk about something specifically in this class. I am working on grading those exams and hope to get them back to you by early next week would probably be the best way to do it. It's a few more short answer questions than I've done in the past since I added a couple, so it takes quite a while, but I'll be working on it. All right, guys. So remember, quiz due Friday. I'll post a video for that class today, and then Monday we'll have another recorded day, and then next week Wednesday we'll come back for our next TBL day where you're preparing for that IRAT and TUAT before you come to class. Okay. All right, guys. Good to see everybody. Hope you get a chance to take a deep breath, get some stuff done, but also get a little bit of rest maybe. I know with all of you being so tired and being so stressed and being the #1 emotion, I hope yeah, you get a chance to get a little rest. So all right, guys, I'll hang out here for a minute if anybody has any questions, but if not, have a good day.